Let me start with a piece of code that looks completely safe. Take a look at this. This code compiles perfectly. It looks safe, but there's a silent bug that could corrupt your data in production. Can you spot it? The problem is what's missing, the commit statement. The transaction will roll back automatically, but your data changes are lost. No exceptions thrown, no error logged, just silent data corruption. Today, we're going to solve this entire class of problems. You'll learn how to encode method call protocols directly into your type system, making bugs like this impossible to write. So, Tony Hoare once said, the great enemy of software reliability is unrecorded intent. Most objects aren't just a bag of functions, they are state machines with rules. A database connection must be opened before you can query it. A transaction needs to be committed or rolled back. A file stream allows writes only until you close it. These are what we call method call protocols, the valid sequences in which methods can be called on an object. The compiler can see that the method like commit exists, but it can't enforce the protocol that says you must call begin first, then do your work, then call either commit or rollback. When protocols live outside the type system, the compiler can't enforce them. That's where our problems begin. When method call protocols aren't encoded in types, complexity explodes throughout your code base in predictable ways. Let me show you how exactly this happens. First, you get latent runtime bugs. Consider this scenario. You open a database connection, and 200 lines of code later, you close it. Then 50 lines after that, you try to execute a query on the closed connection. The code compiles fine but crashes in production. The bug is created in one place, but the failure happens somewhere else entirely, potentially hours later in production. The stack trace points to the symptom, not the cause. Second, you get defensive programming overload. Every method becomes a gatekeeper, checking and rechecking state. Half the code becomes protocol validation instead of actual business logic. Methods that should be simple become bloated with state checks and error handling. Third, your test suite explodes. You're not testing business logic anymore. You're testing every possible way someone could call methods in the wrong order. You end up with test methods that verify dozens of invalid sequences, and you'll never achieve full coverage of all possible protocol violations. Fourth, you get hidden coupling. Protocol knowledge gets scattered across your code base. In one service, you begin a transaction and pass it to a helper class. The helper class now needs to know, has someone already committed this? Should I commit it? What if I forget? Change one class, break something completely unrelated. Finally, there's the onboarding friction. New developers need tribal knowledge just to avoid stepping on landmines. They can't rely on the compiler or the IDE to guide them towards correct usage. When method call protocols aren't encoded in types, you get silent bugs that surface in production. Defensive codes scattered everywhere, exploding test matrices, hidden coupling across modules, and friction for new developers. But what if the type system could eliminate all of this?